Welcome back to the beginning of Chapter 5. Chapter 5 is about quadratic functions. We're going to be looking at how to graph quadratic functions today and a bit tomorrow, and then we'll be getting into how to solve quadratic functions, which includes factoring and a few other ways, and we will also take a trip away from the real numbers, get into numbers that aren't real, and look at quadratic inequalities. So this is it's a longer chapter than the past couple. There are 9 sections, although the few in the middle are kind of split up. Like it could just be solving quadratics, but it does split it up into the different types. This is one of the chapters that people tend to struggle with a bit because it's the first time that it really gets hard. And so that's just something to be aware of as you're going through this. Make sure you keep on top of things because in Chapter 6, we use a lot of what we're learning now, too. So it's not like the last chapter with matrices, which we probably won't use again so much, aside from maybe here and there you might choose to use a matrix to solve a system of equations. These skills will be used in Chapter 6 and Chapter 8 and a few other times throughout the year. And so today we're going to be using transformations to graph quadratic functions, which you actually had a look of in class yesterday or earlier today. And so we'll see some of that, but we'll also look at it from the beginning. So our learning targets for today: I can transform quadratic functions, and I can describe the effects of changes in the coefficients of y equals a times x minus h squared plus k. That should look a lot like what you're doing earlier, except we didn't have h and k, we used b and c. It doesn't really make much of a difference. And so there are some things you should already know about quadratic functions. First of all, y equals x squared would be the basic equation. It's actually the parent function for a quadratic. You should know that it can be more than that. So something like y equals 3x squared minus 2x plus 5 is a quadratic because it has that x squared in it. You can know about the graph. It forms this curvy shape, which is called a parabola. And you can know that we can factor. 2x squared plus 5x plus 2 is the same as 2x plus 1 times x plus 2. And we will get to that later in the chapter. We're not going to be looking at it right now. But that is something that you have already done with quadratics, is you did a bunch of factoring in Algebra 1. And so, how do we graph a quadratic function? Method 1, and if you don't know how to graph something, this is always the fallback, is make a table. Just plug in points and find out what the y values are, plot the points, see what the shape looks like. Anytime you don't have a special way on how to graph it, make a table. And so if we're just going to start with our parent function, y equals x squared, we can have our table. We can plug in our value. And then for our x values today, you're always going to go from -2 to +2. So -2, -1, 0, 1, and 2. Next time we'll see how we can perhaps pick better x values. But right now, it's just use these. It will hit the vertex in that area somewhere. And so we'll be able to see the shape. Because when you're graphing a quadratic, it's important to have the vertex in there. So let's plug in some points. Let's start out at the bottom with 2, because y equals 2 squared, which is 4. And then plug in 1. Y equals 1 squared, 1. You can put that in there. Then how about y equals 0 squared? Well, 0 squared is just 0, so you can plug that in there. Then we can plug in the negatives. Y equals -1 squared. Well, a negative squared is a positive. And we can plug that in. Every year, there are people who insist on not putting these parentheses and they just get negative numbers. And their graphs don't look like parabolas at all, and they always think it's okay, and it's not. Make sure that when you plug in a negative, it goes inside parentheses, so when you square it, it becomes that positive number. And same thing with the negative 2. Negative 2 squared is 4, so we can put that in there. So we have a table of points. Now we can graph them. So we get a graph, we can plot our points, and then connect them in a parabolic fashion. So it should be a smooth curve. You're not just connecting the dots with straight line segments. There should not be a point down here at the vertex. It should be curved. I do understand that there's a little bit of an art to this, but make sure you're working on curving it. And so that's the parent function. How about a bigger one? And we're still just going to make a table for this. So y equals 2x squared minus 4x minus 3. So we get our table, plug in our values, and then negative 2, negative 1, 0, 1, and 2. Again, those are the values we're going to use for x today, unless it tells you otherwise. So let's plug in negative 2. So we have 2 times negative 2 squared minus 4 times negative 2 minus 3. Remember, negative 2 squared is 4, times 2 will be 8. Negative 4, negative 2 will also be 8. So we'll have 8 plus 8 minus 3, and so that's 13. So we can plug that in. Then plug in negative 1. Y equals 2 times negative 1 squared minus 4 times negative 1 minus 3. Negative 1 squared is just positive 1. And then negative 4 times negative 1 is that negative 4. So we'll have 2 plus 4 minus 3 is 3. And so that can get plugged in. Plug in 0. That's my favorite, because this is 0, and this is 0, so we just have negative 3. And plug in 1. So 1 squared is 1, 4 times 1 is 4. So we have 2 times 1 minus 4 minus 3, which is negative 5. And then plug in 2. We have 2 times 2 squared minus 4 times 2 minus 3. 2 squared is 4, 4 times 2 is 8. Then 2 times 4 is 8, minus 8 is 0, minus 3 is negative 3. So one of the things we'll talk about next time is about the symmetry of a quadratic. We have these negative 3's, which means the vertex is directly between them. In fact, the vertex will be at 1 comma negative 5 in this case. But being that we have the same number, it's been going down, and then it starts going back up again. That means we captured the vertex in our points, and we can graph them. So if I take my graph, well, this graph is not big enough for these numbers. So let's get a graph that is. Plot the points and connect in a parabolic fashion. Now with the whole symmetry thing, if you wanted to find a couple other points, if you go over one more this way, it'll be that same value. And if you go over one more, it'll be this same value. And so that's make a table. Again, just plug in the points, make sure that when you square the negative, it becomes positive, and then plot the points. So you're going to try this one now. So you have y equals x squared plus x minus 2. So make a table, plug in those x values, plot your points, and see if you can get this. So go ahead and pause this, and then push play when you're ready to come back. How did you do? Do you think you have it? Does it look like a parabola? If it doesn't curve around and come back up again, make sure you squared those negatives to be a positive. Let's take a look. So we have our table. Get our value in there. Our x values. Then we can start plugging stuff in. So negative 2 squared plus negative 2 minus 2. Negative 2 squared is 4. Minus 2 is 0. And plug in negative 1. Negative 1 squared is 1. Minus 1 minus 2 is negative 2. And then plug in 0. That's just negative 2. And plug in 1. 1 squared is 1. Plus 1 minus 2 is 1 plus 1 minus 2, which is just 0. And then plug in 2. 2 squared is 4. Plus 2 minus 2 is just 4. And so when you look at this, the change is right in here, which means we did capture the vertex. It's just not at one of our points. It would be at negative 1/2. That's okay. We could find that point if we wanted to, but when we're graphing, if we follow the points, it'll actually work out okay. So we can have our graph, plot the points, and connect the dots in a parabolic manner. So by following, come down to right about here and go up. Now I wouldn't use this to find the vertex, but for a graph, that's going to be as close as we're going to get anyway. Alright, so how'd you do on that one? Did you get it? Did it look like that? I hope so. If not, did you see where you made a mistake? Alright, so that was the first method on how we graph quadratic functions. The second method is by using transformations. And this is what we were looking at in class either earlier today or yesterday, depending on when you're watching this. So to use transformations, we start with our parent function, which is just y equals x squared, which looks like this. And then if we want to move it horizontally, we subtract inside the parentheses. So like say x minus 2 is going to move it 2 units to the right. And so it puts it over there. If we wanted to move it vertically, we add something to the outside of the parentheses. So we just go plus 3 on the outside, and it would move it up there. Now most of the time, we'll be doing both translations, because this takes the vertex from 0, 0, and in this case it'll move it 1 to the left and 2 up to put it up there. And so this is your vertex. In the calculator deal, you found, oh, if I put my vertex as B and C, then the vertex will be on the point that you're looking for because of the transformations. So try this one really quick. It should not take very long. Y equals x minus 2 squared minus 1. So go ahead, pause this, graph it really quick, see where it should be in your sketch. Did you get it? Did you remember that this would be x minus 2? It's going to move it right, just like this one did. And this one moves it down. And so we have that positive 2 comma negative 1 would be the vertex. Forgetting that the sign is changed is one of the common mistakes in this. And there's vertical stretches and compressions. That's where we're going to multiply something to the outside of our x. And that's just going to stretch or compress. So if we have 2x squared, that's just going to stretch all the y values by 2. So instead of at negative 1, 1, we'll be at negative 1, 2. We'll be at negative 2, 8. 1, 2, and 2, 8. The 0, 0 stays the same because 0 times 2 is still 0. And so this would be a vertical stretch because we're stretching it up too. You might think, well, this is also a horizontal compression. True, it is also a horizontal compression. But with quadratics, we tend to think more of just a vertical stretch or compression. And then if we had a negative stretch or compression, that would flip it into an upside down parabola or a sad parabola. And so our general equation, y equals a times x minus h squared plus k. H moves it h to the right. We saw that. And k moves it up. And then a is going to be a vertical stretch. So the vertex will be at the point h comma k. Now this is very, very similar to absolute value functions. Honestly, the only difference is we have parentheses and squared instead of just the absolute values. Everything else is the same. The vertex moves to exactly the same place. They were lines, and so we had a slope. In this case, we don't really have a slope, but it is the same. And a little secret, transformations will be the same every single time that we do them. Anyway, that was 5.1. I will see you in class, and until then, happy mathing.